Hello everyone. Welcome to this video presentation of understanding inheritance and its challenges in object-oriented programming. Like what challenges or issues inheritance faces. Before we start, I will like to tell you the some pillars of OOP, which are mainly four, which are abstraction, encapsulation, inheritance, and polymorphism. So we are going to dive into the inheritance. Let's begin what inheritance is. In the context of object-oriented programming, inheritance is a fundamental concept in OOP where a new class inherits properties and behavior from an existing class. For example, as you can see in an image, a base class is called transaction. With properties like account and amount, we can create a derived class withdraw transaction, deposit transaction, and transfer transaction that inherit these properties of the base class, which is transaction class. Let's talk about some types of inheritance. There are four types of inheritance. Single inheritance. In single inheritance, a derived class inherit properties and behavior from a single class, from a single base class, forming a linear hierarchy of classes. As you can see, multiple multiple inheritance. Multiple inheritance allows a derived class to inherit properties and behavior from a multiple base classes, creating a complex relationship. Multi-level in multi-level inheritance, a class can inherit from another class, which in turn can inherit from another class, forming a chain of hierarchy of inheritance. Hierarchy inheritance occurs when multiple derived classes inherit from a single base class. This creates branching structure where several classes share a single ancestor. Now let's talk about some issues of inheritance, famous issues, which are namely fragile based class problem, diamond problem, and tight coupling. First, let's talk about fragile base class. This problem occurs when you have a base class that many other classes inherit from, and you make changes to the base class unintentionally that breaks the functionality of derived classes. For example, consider a shape class as a base class who has a property area. If we later modify the area calculation logic, it can affect all the derived classes like circle and rectangle. So to avoid the fragile base class problem, developers can use techniques like encapsulation, where you hide the internal implementation detail of the base class. By encapsulating the area calculation in a method and making it protected, we provide a stable interface for derived classes while allowing internal changes. So this is how this problem can be avoided. Now let's talk about the diamond problem, which is quite famous in object-oriented programming. This diamond problem is a specific to multiple inheritance and occurs when a class inherits from two or more classes that have a common base class. For example, imagine a person student and faculty class, if student and faculty inheriting from a person class, if and faculty have student and faculty have get name method. When we create an instance of TA, sorry, like person, student and faculty is inheriting person, and TA is inheriting student and faculty, and this get name method is being like being accessed by student and faculty. And when TA when we create an instance of TA, it will call get name method, then it will create an ambiguity. Like ambiguity can be arise when derived classes means this can attempt to use methods or attributes inherited from the common base class. So this is an issue in diamond problem. This problem in C# is fixed by not allowing the multiple inheritance, but by allowing interface implementation in case of this. So this is how diamond problem can be fixed. Let's talk about last, tight coupling problem. Tight coupling occurs when classes in an inheritance hierarchy are closely connected and depend on each other, making it challenging to change one class without affecting others. For example, consider a vehicle class and a car and motorcycle derived from vehicle class. If changes to vehicle affect both car and motorcycle, we have a tight coupling problem. So the solution for this is to reduce tight coupling in developers should use technique like which favor coupling over inheritance. Which favor like instead of using inheritance, developers should use like compositions. Instead of inheriting all the behavior, a class can use composition to include only the required functionalities. By creating a separate class, for example, like by creating a separate class of engines and wheels, in the example of vehicle, car, and motorcycle, like a vehicle, car, and composing them with the car and motorcycle, we can achieve loosely coupling and flexibility. So this problem can be reduced. In conclusion, inheritance is a powerful concept in object-oriented programming, but it has some challenges, but these issues can be fixed. At last, I have created a one blog for related to diamond problem. If you want to get in more depth, like understand what diamond problem is and what kind of issues inheritance can face. Hope you like my presentation.